Okay, chemistry, metals and nonmetals and metalloids. So as you can see from our periodic table here, it is categorized in another way here. Okay, and that's by separating it into metals, metalloids, and nonmetals. So our blue one, okay, which is the majority of the periodic table, these are all metals. Okay, the middle one, the green one, here we call this the staircase. We'll talk about it later because it's kind of in the form of a staircase. Um, these are the metalloids, okay? And the nonmetals are these guys right here. This one here, which is hydrogen, and then all these guys over here are all nonmetals. So each of these classes has characteristic chemical and physical properties. Okay, they have both, and so we're going to talk about both for each of these categories. By knowing whether an element is a metal, nonmetal, or metalloid, you can make predictions about their behavior. Okay, so the first one, it's a physical property for metal. It has a luster. Okay, this means a shine to it. Most metals are silver or a silver gray in color, except for gold and copper. Okay, these two here. You probably have seen Home Alone. Came out in 1990. This robber here tried to grab the door. The kid heated up the doorknob because metal conducts heat. Now, not to debunk this one, but you can't actually heat up a doorknob that hot. So don't try it. Please don't try any of these things.
Yes.
The next one, a physical. Okay, our next one is malleability, or whether something's malleable. That means that it can bend. See these guys from The World's Strongest Man, my birth year, 1981, are bending, metal. So metal is malleable. Another one of the physical properties of metal is that it is ductile, or it has ductility. This means it can be drawn into a wire. So you can see here in the video that the rod is running through a machine that contains a series of lubricated pulleys and dies, stretching the thinning it out as it goes. This ability to be drawn into a wire is called ductility. Okay, another one of the physical properties of metals is that they're all solid at room temperature, except, and I give you the picture here because it's the only exception, except for mercury. Okay, sometimes has been used in the past in thermometers, is not anymore. A very toxic material, mercury. Okay, but if you ever want to see fun with mercury, go take a look at some mercury stuff online and see how really seemingly heavy things will float on the surface because of the surface tension. Another one, okay, another physical property of metals is most have a very high melting point. Okay, you may recognize this from Terminator 2 Judgment Day. Of course, the Terminator itself was made of metal, and so it self-destructed. Actually, it didn't self-destruct. It got lowered in to this because it cannot self-destruct, if you remember correctly from the film. It and melted down with the rest of the metal. Okay, this is actually a fallacy. If he were to have been lowered, he would have sat on top of the surface tension would have held him on the top of the liquid metal, and he would have melted into it from the top. He would not have sank into it. So, but anyway, sorry if that ruins anything for anyone, but that wouldn't be possible. Okay, scientifically speaking, chemical properties, with the exception of tin, lead, and bismuth, metals have 1, 2, or 3 valence electrons. So that's when we're talking about chemical properties of metals, that's what we're talking about. Okay, now we're moving in. These are still metals, but we're talking about more specifically because most of the metals are not the main group metals. Okay, groups 3 through 12, beginning with period 4. Okay, if you orient yourself on the periodic table, and going to the bottom of the table are transition elements. Okay, all transition elements are metals. Okay, the chemistry of transition metals is more complex than that of main group metals due to their complex atomic structure. Okay, so the inner transition elements, you'll notice that at the bottom of the periodic table, there's a group of elements. You're not quite sure why they're underneath. This is why they're underneath. Okay, two series of elements. Atomic numbers 58 through 71 and 90 through 104 are placed below the main body of the table, because putting them into their proper position would make the periodic table very wide, and so we put them underneath. And these two series of elements are called the lanthanides and actinides. Okay, the lanthanides are given their name because they follow element 57, lanthanium. The lanthanides are also called rare earth metals because their natural abundance is less than 0.01%. Okay, very little. And all the lanthanides have similar properties. Okay, and so here we have a picture of some of the lanthanides. Okay, the actinides. Okay, so all the actinides are radioactive. None beyond uranium occur in nature, so they are man-made. You can see a bomb exploding there. They're man-made. Their chemistry is unpredictable because of their atomic structure. Okay, as you'll see in this video, when we're talking about
when the flash hit you, you could see the x-rays of your hands through your closed eyes. To say it was frightening is an understatement. We were basically used guinea pigs. There's no other word for it.
So I'll leave it at that, but that is one of the times that the actinides are present, okay, or are created. So nonmetals are very abundant in nature. Oxygen and nitrogen make up 99% of the Earth's atmosphere. Okay, so you can see here the 79%. 78 point something, but 79% here, nitrogen and then oxygen here make up a great deal of the Earth's atmosphere. Most of the air around us is nitrogen, just an FYI. Carbon is found in more compounds than all other compounds combined. Okay, we are carbon based. All living things are carbon based on this planet. So carbon is a very, very plentiful element on Earth. With the exception of carbon that has 4 valence electrons, the nonmetals tend to have 5, 6, or 7 or full valence electrons. Okay. More physical properties of nonmetals. Most do not conduct electricity except for carbon. Okay. Most are poor heat conductors. You'll notice that these are kind of the opposite of metals, right? Most are, you think of metals are hard. Okay, most non-metallic solids are brittle, or they'll break easily. Okay, metals aren't known for breaking easily. Many are gases at room temperature. So this is a group of kids that I took to the science gallery at the Manitoba Museum, and so this is to demonstrate a gas. This is actually hydrogen. It's a balloon filled with hydrogen. You can see it's in the dark. A stick. This is a candle. It's a candle and a meter stick, and they're lighting it on fire. And it's pretty fun.
Fire
They lack the luster typical of metals. So they don't have that shine that metals have. They're more matte, more flat color. Okay. Their melting points tend to be lower than that of metals. Okay. Now on to metalloids. Okay. Metalloids have some physical and some physical and chemical properties of metals and others of non-metals. Okay, they act mostly like non-metals but conduct electricity very well. Okay, and are also called semiconductors. This means that they're very important for electronics, right? Your phone, your TV, your computer. They all have semiconductors in them. Okay, the microchips, and they can easily control the flow of energy. Okay, how much, the direction, stop and go, stuff like that. So I will leave this. If you want to go and check this out, you can go check that out. Metals, nonmetals, and metalloids, differences in their properties occur because of the different ways that electrons are arranged in the atoms. Okay, so that's why there's differences in the properties. It's the arrangement of the electrons, the number and arrangement of the valence electrons, and how tightly the atom holds those electrons are important factors in determining the behavior of the element. Okay, in metals in general, the valence electrons of metals are loosely bound to the positive nucleus. Okay, remember the nucleus is positively charged, and those valence electrons, the ones on the outside, are very loosely attached. Okay, they're free to move into solid metal and are easily lost. This is how electricity flows. Okay, is the flow of these electrons. Metals tend to lose electrons in chemical reactions, okay? And this freedom of motion accounts for the ability of metals to conduct electricity. I guess I already said that. Nonmetals and metalloids. So the valence electrons in atoms of nonmetals and metalloids are tightly held, okay, and are not easily lost. When undergoing chemical reaction, nonmetals tend to share electrons or gain electrons from other atoms. This will be really important next year, okay, in grade 10 as you're learning about compounds and chemical reactions. Okay, so where do you see this on the periodic table? What is this called? What would you call this here? You're testing yourself. I talked about it at the beginning of the notes. Okay, the staircase. Okay, so I just wanted to review where the staircase was as a reminder because it's important. It's kind of where everything is divided, right? We have these metalloids, these things they have properties of and chemical and physical properties of metals, but they act more like non-metals, but they can conduct electricity, right? And then on the other side we have these metals that are all very common, and then on the other side we have all these non-metals.